Class 9, next topic in this chapter is separation of components of a mixture. If we have mixture of 2-3 things, how we can separate all the components of a mixture. So different techniques we will be studying here in this topic. For different type of mixture, different kind of techniques are suitable for removing the components from that mixture. So first technique that I'm taking here is evaporation process. By evaporation, how we can separate the components of a mixture. And I'm taking example of separation of colored components from an ink. If we take some ink, blue color or black color or red color ink we take, that has two things in it. One is a colored dye in it, and second thing is a liquid in this. Separation of colored component from blue or black color ink. So from that, how we can separate that solid thing from an ink, that is called a blue or black color dye. And one more example we have in evaporation that we all know is how we can separate the salt from the seawater. From seawater, the salt is also separated by the same process, that is evaporation. So what we do in evaporation now here, so ink we take, ink is homogeneous mixture. Homogeneous mixture means the components, they have mixed up uniformly here. The solid dye and the liquid, they mix up uniformly here. So the dye component of ink is separated by a process of evaporation. The procedure for this is, we will first of all take a watch glass. In the watch glass, we will take the ink. Like suppose we have I'm taking a blue color ink here. This is watch glass. And in this, what we have taken is ink we have taken. And then we will take a beaker. In this beaker, we will take water. Water will fill in this. This is water. And we have to heat this water. So this whole thing that we have to keep over a stand, tripod stand we are using here. On the tripod stand, this is a mesh that we keep here, and then beaker that has water in it, and we have to heat this using a burner. This is burner that we have. And here we are keeping on the top of this beaker, this watch glass. This watch glass we are keeping here that has ink in it. So we are not heating this ink directly by keeping this watch glass on this flame. First we are keeping a water here in a beaker. The water will get heated, and the heat of this water will be given to this ink, and from that what will happen, the liquid component will start evaporating from this slowly and slowly. Direct heating we cannot do because the ink can decompose. In that case, even the dye also can decompose. So this method is actually called indirect heating. So when we are heating it, then the liquid is evaporating from this thing. These are the vapors of the liquid part which is there in a dye. And then slowly and slowly what will be left behind in this watch glass, what we see in a watch glass is, this is watch glass. And since we have taken a blue color ink, so we will just see the blue component left here in this, a thick solid blue component here. So this is a blue dye. So after evaporation, we will get this thing. So this is how we can separate the colored component from blue or black ink by using which method? Evaporation. Similarly, from the seawater, by evaporating the water, what will be left behind? Only the salts will be left behind. So the salts we can separate from the seawater by the same technique, that is evaporation. This is the first method. Now moving on to the second method. This method is centrifugation method. Centrifugation method. In centrifugation method, I am taking the example of separation of cream from milk. Separation of cream from milk. For centrifugation, a machine is used, and that machine is called centrifugal machine. It's like this, a big container we have. Inside this, there is a rotator. With rotator, there are 4 tubes. These are empty from inside. 3 tubes or 4 tubes or more than that, also different kind of centrifugal machines are available. This is centrifugal machine attached on a stand here. So in these tubes, what we do is we take a test tube. In the test tube, we'll take a mixture that we want to separate. Like we'll take milk and we want to separate the cream from this thing. So that we'll take in this thing. Suppose here we have these liquid milk is there. And then this mixture is rotated at a high speed. This machine moves like this. When it's moving at a high speed, the lighter particles, they will come at the surface. And the heavier things, they will start settling down at the bottom part, because both these things, they cannot move with the same speed. Heavier particles, they cannot move fast, so slowly and slowly they will be at the bottom part, and lighter particles are moving fast, so slowly and slowly they will come to the surface. So mixture is rotated at a very high speed. So when milk is rotated at a high speed in this centrifugal machine, the lighter fat particles, fat here is cream is light. So lighter fat particles, they will start combining together and they will form a cream, and they will be at the surface. And the heavier milk, that will remain at the bottom part. So before centrifugation, when we are taking this test tube, then we will see the liquid here inside this. This is milk which has cream also in it. So this is before centrifugation, before centrifuging this. And after centrifugation, what will happen? Now, at the bottom will be this clear liquid, and the lighter thing, since I have taken the example of milk here, so in this case the cream is light, so this cream will come on the lighter cream. So whichever component is light, that will be on top part. The one that is heavy, that will be at the bottom part. So in this way, we can remove the cream from the milk by using which technique? That is centrifugation. In centrifugation, we are taking the help of centrifugal machine. In that, we'll take up the components and it is rotated. With a fast rotation, the lighter particles will come on the top part and the heavier particles, they will settle down. So this is a second technique that is called centrifugation. Now moving on to the third technique here. This is sublimation. Example for sublimation I'm taking is separation of a mixture of ammonium chloride and sodium chloride. So when we have mixture of ammonium chloride and sodium chloride, we know that ammonium chloride, that undergoes sublimation. Ammonium chloride undergoes Sublimation, that is why we're taking the help of this technique here. In this technique, what we do is we take a china dish. This is a china dish, and in this china dish we'll take the mixture of ammonium chloride and sodium chloride. Both these are white color salts, so this is just a mixture of ammonium chloride and sodium chloride. Mixture of ammonium chloride and sodium chloride. And then we have to cover this china dish with a funnel. We'll take funnel with an inverted funnel. So the funnel we have to keep on the top of this. Inverted funnel we will have here. Just to close this mixture. Inverted funnel. And then the stem of this funnel, this also we have to close. So this we have to plug with a cotton plug. So we'll close it. Now after this, the next step is we have to heat this mixture now. This mixture is heated again by keeping this over a tripod stand. In lab for heating, we take the help of a stand that is called tripod stand. And under this we have a burner. On heating this mixture, what will happen? What we will observe in this case? Burner. This is a tripod stand. Whenever we're drawing a diagram, the labeling, it has to be complete, and diagram should be neat, labeling should be neat, and it should be in a straight line. You can't write diagonally here, so it has to be straight only. Then this is the wire that we'll keep here. When we heat this mixture, what we'll see? Dense white fumes they will form. So dense white fumes, they will start forming up here in this. And these are of ammonium chloride, because directly solid will change to the vapor form only in the case of ammonium chloride. It will not change to liquid form first of all. It will directly change to the vapor form. So these white fumes which will form here, they will start sticking to the sides of this funnel. Why they will stick to the side of the funnel? Because on heating they will change to vapor form, and this funnel is cold. So when the vapors will touch the cold parts of the funnel, they will condense. So when they condense, they will stick to the side of this funnel. So here we will see the ammonium chloride. So maybe this color will not be visible to you, so I am just taking this blue color only. Otherwise, remember, these are of white color. Both the salts are white in color. So this will stick to the side of the funnel as powder, and sodium chloride will be left behind. And then we can move the funnel from here. All this powder that has stick to the side of this funnel, white powder, we can scratch it, we can remove it. That is ammonium chloride. And what will be left behind here in the china dish, that is a sodium chloride. So taking up the help of this technique, sublimation, we can separate the two components in which one component shows sublimation and another component does not show sublimation.